In the first experiment, we melted chocolate in my hand, and at first I noticed that the bar of chocolate that I had chosen was a very dense solid. It was not flexible, not movable, it was very dense, and it couldn't change its shape. Then, as I held the chocolate in my hand, I realized that I could feel it start to change its solid form. In that case, I noticed that it was changing substance as well when I opened my hand to see that the chocolate had completely changed its shape and form. It was then a liquid. The chocolate was melted into a liquid substance that was easily reshaped and movable. I could move the substance, I could spread it throughout my hand, and so I knew that there was an obvious change in state. So when we use models to model something like what happened here with the melting chocolate, something we need to understand is that it needs to illustrate the concept that matter is forever. When we're using it to model the molecular scale like we are doing here, atoms and molecules are forever. They're never destroyed. Just because I changed the substance doesn't mean I lost some of this scale. So, when we use models, we're using something to represent this larger idea or something that's often hard to visualize or represent. So here, as you can see with the paper clips, we are using one paper clip to represent an atom, and the linked paper clips represent the molecules. So here I have illustrated the three chocolate molecules we started with when the chocolate was in the solid cube form. So as you can see, the paper clips that represent the molecules are linked together in three different molecules, and they are tightly packed together to show that this has created a solid substance. Solids have tightly packed molecules that the only motion that is allowed in those molecules is a vibration. So here we're showing that they're very tightly packed, there is little movement, and that this substance is in fact a solid. So now here with these paper clips, we are representing what happened after there was a change in state for the molecules. As you can see, there are the same number of atoms and molecules, obviously, because the matter was neither created nor destroyed. And all we see is a change in both motion and arrangement of the molecules. We can see that the molecules themselves are farther apart in arrangement, and that because they are farther apart, we have the ability for those molecules to slide past each other, and that is what makes the molecular scale, the characteristics of the sliding past each other and the increased room between the molecules, it is what makes that solid turn to that liquid. So this is how we're representing what happened when I held that chocolate in my hand and it turned from a solid to a liquid. So much like how we used models to show the molecular scale of the chocolate, we can use models to show what happened in terms of energy when we made that change from a solid to a liquid. So when there is a change in substance like that, there has to be some type of energy involved, because energy is what allows that arrangement and motion of molecules to change. So here we are representing the same idea that energy, like molecules and atoms and matter as a whole, is forever. So you'll see, much like in the paperclip model that we just used, that there is the same amount before and after the transformation. And that is important because that is the concept that we're trying to get through here, is that although there was a change that happened, nothing was created or destroyed by that. So here we are illustrating the energy transfer from my hand to the chocolate, which caused the change in substance from a solid to a liquid. So my hand was obviously warm from the warmth of my body heat, and when I placed the chocolate in my hand, I was able to transfer the warmth from my hand to the chocolate, which was able to melt the chocolate. So melting was the change that happened there. So we see that the 3 units of thermal energy that were taken from my hand were transferred to the chocolate, which gave it the ability to change from a solid to a liquid. For the second part of the project, we used stain removal tactics to remove 2 different types of stains from a white cloth. So I chose chocolate and red wine for my 2 stains, and I also chose OxyClean and bleach as the 2 agents to get rid of the stain. So here we'll be showing the red wine stain, which was the stain that came out in both OxyClean and bleach. So both of those stain removal agents were able to dissolve the stain completely, and we're going to show what happened in that chemical change to make that happen. So as you can see here, I used OxyClean on the top stain and Clorox bleach on the bottom stain, and it shows that at first when pouring the 2 stain removers onto the stain, we can see that most of the stain was gone, but not all. So then in the second photo, after sitting for 24 hours, you can see that both stains are completely gone and changed. So now we're going to show what happened in that chemical reaction in order for these stains to completely disappear. So once again, all the matter was all there. All the energy that was given was still there. There's still the same amount, but something happened to make that stain go away on the cloth.
So here you can see I have the red wine molecule mixed with the 2 OxyClean. I'm sorry, next to the OxyClean molecules. So they were both separate molecules. I have 2 separate molecules of OxyClean, 1 molecule of red wine. So you can see that those are separated. And then when the chemical reaction occurs, you will see that the molecules will completely change. Also in this model, we're using the blue and white paper clips to represent both the OxyClean and the bleach because they both had the same reaction. They both took the stain out of the cloth. So we are showing them as just one molecule. And actually, bleach and OxyClean have very similar properties. So I just represented them here with both the blue and white paper clips to represent what happened with both of the red wine stains with the OxyClean and the bleach. So when the OxyClean and bleach reacted with the red wine were formed, new molecules were formed from these atoms. We see we still have the same number of atoms because atoms and matter cannot be destroyed, but they are in different groups. So as you can see, some of the red wine atoms mixed with the OxyClean, and those atoms are representing the ones that have the coloring in them, that dark red color. So that's why we saw the color change happen, because there was a chemical reaction and there is now a new substance because new molecules were formed. So when we look at the energy reaction, we will see that the energy that was put in chemically will change based on those new groups we created, because now that those groups have changed, so will the amount of chemical energy that goes into each group. So when we look at the chemical change that occurred, we see that at first we had the molecule A, which was the large red wine molecule that mixed with the two B and C molecules, which were the bleach or OxyClean molecules. And then they all had the chemical energy. And then when the reaction occurred, they were split into different molecules. Two molecules that mixed the red wine and the OxyClean or bleach together. And then we were left with just one smaller particle with red wine in it. So we can see that the new molecules were formed, and so that chemical energy was transferred from 3 molecule groups to 3 new molecule groups. You see we still have the same amount of that chemical energy, but they are just now grouped in different groups. This also occurred when I used the chocolate. All of my stains were also dissolved, so I concluded that something similar to what I modeled here happened also with the chocolate.